Hi everyone, here is notes on solving by graphing and factoring. So in this section of the notes, we're going to be talking about how to find the solutions to a quadratic by looking at a graph and also doing it algebraically. So the thing that we want to go over in Algebra 2, which comes up often on the SOL, is vocabulary. And so the word solutions, the word roots, the word zeros, they all mean the same thing. They're all where the graph crosses or touches the x-axis. A lot of times on the SOL in the directions they'll use the word solutions, then they'll change in a different question and they'll say the word zeros. And then they'll change in another question and they'll say the word roots. But really, it's all the same thing. It's where the graph crosses or touches the x-axis. So here's some different situations that we can have here. We could have a graph that has two real solutions. So maybe if I draw a parabola that looks like this is not any particular equation, it's just a sketch. And you can see that with this parabola, it crosses the x-axis 2 times. So that has two real solutions. One solution is right here. The other solution is right here. In fact, I'm going to draw arrows to them so that they kind of stand out. We don't care about the y-axis. We only care about the x-axis. So that would be a parabola that has two real solutions. And then the next possibility would be a parabola that maybe only has one real solution. And so that would be one that just comes down and touches the x-axis and kind of bounces back off. So right here, this would be just that one real solution that that parabola would happen to have. The last situation would be a parabola that has no real solutions, doesn't touch the x-axis at all. So maybe that one would look like this. And it doesn't matter if they're face up or face down. Face down parabolas can have solutions and face up parabolas can have no real solutions. I could draw another face up parabola up there. Both of these parabolas do not touch the x-axis, and so they would be examples of equations that wouldn't have any real solutions to them. So those are your three possibilities, and I'm going to show you how to find them algebraically. In order to find them algebraically, you need to know something called the zero product property. And so for the zero product property, that means if we have a product means multiplication. So if we have two things that are being multiplied together and they equal 0, we're allowed to break this up and we're allowed to say that each one of those parentheses, each one of those factors, to bring us back to Unit 2, can be set equal to 0. We're allowed to do that. We're allowed to take this one and set it equal to 0. We're also allowed to take this one and set it equal to 0. And that's saying that in order for this product to equal 0, one of these factors must have to be 0. 0 times anything is 0. So to get this by itself, you would add p. And p and q are just numbers. They can be any integer. So you would solve that and x would equal p. And then over here you could add q to both sides and x would equal q. So when you solve this and get the x's by themselves, these things, these answers that you get, represent the solutions. Okay, so this is a solution and that's a solution. Okay? So this is what we're going to do. First, we have to set it equal to 0. Okay? So set it equal to 0 first. So that means we're going to move this 6x over here. So x squared minus 6x equals 0. Now, we're going to do some factoring. That's why you had to do all that factoring in Unit 2. It's all leading up to working out these quadratic graphs. So to factor this, don't look at the 0, just look at the x squared minus 6. You're going to take out a GCF, right? You've done a million of these, so you know how to do this. Take out the x, then you're left with x minus 6 equals 0. Okay, now we can't factor that any further, and so this is a product. These things are being multiplied together. If you want to put parentheses around this x, you're welcome to. We can set each one of these now equal to 0. So x equals 0 and x minus 6 equals 0. Now get the x by itself. This x is already by itself. This we'd have to add 6 to both sides. So x equals 6. These two answers are your solutions. If you were to graph x squared, well, in fact, let's actually graph it so you can see how this works. So I'm going to put it in my y equals. I have to put it in this form because I can't put an equal sign in my y equals. So I'm going to put it in after I've set it equal to 0. I'm going to do x squared minus 6x, and I'm going to hit graph. Okay, we get a nice parabola. Do you see that our parabola crosses the x-axis at 0, which was one of our answers, and then it also crosses at 1, 2, 3, 4, 5, 6, which is my other answer. So when you're doing this by hand, you're really finding where that graph crosses the x-axis. That's what you're doing by hand. Okay. Let's do the next one. Example number 2. Get it set equal to 0 first. So I'm going to subtract the 15. 2x squared plus 7x minus 15 equals 0. So now, in order to solve this for x, we're going to need to factor it. This is quadratic, so I got to factor it. And it's a trinomial. I don't see a GCF, so we're going to go right into 2 times negative 15. Which is negative 30, and a is 7. So two things that multiply to negative 30 and add up to 7. Looks like we need to do 10 and 3. And let's make the 3 be negative. That should work out for us. So remember how we did this in Unit 2. Scratch this out. Put the 2x squared down. Then I'm going to write plus 10x minus 3x minus 15 equals 0. Now we're going to put these two together. We're going to put these two together. Take out a GCF. 2x. You're left with x plus 5. Bring down the minus sign. Take out a GCF, which is 3. And then x plus 5. So our factors will be 2x minus 3 times x plus 5. That's an example of the zero product property. You have two factors, like up here, two factors down here that multiply to 0. So set each one of them equal to 0. Remember, you can always pause the video if I'm going fast. Feel free to pause it so that you can catch up and write everything down. So add 3. 2x equals 3, divide by 2, x equals 3/2. And then on the other side, subtract 5, so x equals negative 5. So our two solutions are x equals 3/2 and x equals negative 5. Check them in your calculator. Graph this equation and see that the graph crosses at 3/2 and negative 5. Let's do these last two examples. So the last two examples are set equal to 0 for us already. That's good. So all we have to do is factor. So let's see, that's a 1. 1 times negative 18. So what multiplies to negative 18 and adds to 3? So let's see, how about 6 and negative 3? So this will be x squared plus 6x minus 3x minus 18 equals 0. Then you're going to group it, take out an x, you're left with x plus 6, bring down the minus sign, take out a 3, you're left with x plus 6, and then this becomes x minus 3 times x plus 6. Now, using the zero product property, we can now set each one equal to 0. X minus 3 equals 0, so x equals 3. X plus 6 equals 0, so we subtract 6, right? So x equals negative 6. Just to convince you, let's graph it. X squared plus 3x minus 18, graph. It's a really big parabola. It gets a little cut off there. And so you can see that right here at 1, 2, 3, 4, 5, 6, negative 6, there's one x-intercept, which was one of our answers. And then at positive 3 is our other answer. So that's how this relates to the stuff that you're doing by hand. Okay, so let's do this last one. It's set equal to 0. We need to figure out what multiplies to 64 and adds up to negative 16. So it looks like negative 8 and negative 8. Cross this out. Bring down the x squared. Minus 8x plus 64 equals 0. Okay, group these two and group these two. Take out a GCF, x. You're left with x minus 8. Take out a negative sign. Ooh, and an 8. That works. That'll be x and then negative 8 to give me positive 64 equals 0. So this will be x minus 8 times x minus 8 equals 0. Well, it looks like we've got two of the same thing. So you don't have to set it equal to 0 twice. It's going to come out to be the same answer. So it's just going to be x minus 8 equals 0. Therefore, x equals 8. So here's an example of a quadratic that only has one solution. So that picture is going to look something like this. Okay? And let me show you how that works out. We go to the calculator and put our equation into the calculator, the original one. It'll be x squared, let's see, what was it? I scratched it out. Minus 16x plus 64, hit graph. There's your parabola. Oh, can't see it very well on the screen, can you? There's your parabola. So, right here at this spot, the parabola comes down, hits the x-axis, and bounces off. That is at 1, 2, 3, 4, 5, 6, 7, 8, just like what we got. This, since you got the same thing twice here, this is called a double root. It means that it's just the same answer twice, and it's going to bounce off the x-axis. Okay? Alright, so that concludes the notes on solving by factoring. Try the practice exercises, and of course, if you have any questions, feel free to ask me. Thanks a lot.